In BD4DER, I think the main challenge that all of our pilots have is how to come up with such analytics that would comply with the requirements of many stakeholders involved. This, for example, can be the requirements of flexibility service provision that the distributed energy resources need to comply. That could be the requirements of the distribution network operator for the connection rules. And the other challenge that most of the pilots, I think, also face is that there is a big volume of information that needs to be taken into account in order to make informative decision. It starts from the weather data that you need to leverage. You will need to consider the uncertainty of the weather, of the climate. You will need to consider the stochastic behavior of the users because they can affect how your controllable devices will work. It may also be the challenge of other markets to decide to what market to optimize your flexible resources. So there are many opportunities, and overall this has to be done in an efficient and scalable manner, because in majority of the cases the distributed energy resources, they are rather small, and the amount of flexibility that you can extract from them is rather small. But at the same time, when you develop the analytic solution for individual assets, you might need to spend a lot of training resources, computational resources for their training, and coming up with a method that works efficiently would reduce the cost and would eventually help to reduce the energy bills of the end users. The main concept of BD4 distributed energy resources pillar is concerns the optimizing the management of distributed energy resources connected to the grid. These resources, they have a flexibility potential that can be leveraged for the whole energy system. However, it's a challenging task to integrate these resources into the end system, because there is already established grid operational concept, there are established energy markets, there are new emerging business units like local energy systems or community energy systems, and this optimization of these resources requires to deal with a lot of uncertainties on a long-term scale. And in our pillar, we addressing these challenges by developing the predictive analytics for the management of those resources. The partners within our pillar, they work on such problems as profiling the flexibility potential of energy resources, coordinating their management between the resources and distribution network operators, providing the forecast for production and demand, as well as optimizing the management of resources for reserve services, for example. Yeah, I think the main improvement in terms of the functionality comes from the analytics developed for the predictive analytics developed for the forecasting services mainly. These services enable many stakeholders to make informative decision for the energy management of distributed energy resources and optimize their performance. In BD4DER, I think the main challenge is that we need to require to process a large amount of information, but the difference of this information in comparison to maybe a large-scale asset is that it should be location dependent and it should be on a high granularity, and this causes a significant problem in terms of the volume. We can, using this data, we can extract the insights about the asset state, anticipated asset state. We can extract the information about the condition of the local networks. We can also project how this state and conditions will evolve in the near future.